Hello everyone. In this short video we're going to talk about triple integral evaluation. First, I would like to spend a few minutes of the time to discuss why do we have to even do that. We did the single integral, double integrals, right now triple integrals. But let's go back to calculus 2. If you remember, they gave you a function such as y equal to square root of x, and they give you the boundary point that your x is from 0 to 1, and this is 1 and 1. And they said revolve this around the x-axis or the y-axis, then you create a revolution of solid. And you were asked to find the volume of that one using the single integral. First, you went and pulled one disk out, and you said the volume is the base area, which is pi r squared, times the thickness, which is a dx. And we do it with respect to x because our x is fixed, and then we can make the thickness of each of these disks a dx. Then we said we're going to evaluate it from 0 to 1, pi r squared dx. But remember, the radius must be the same fabric as the variable of integration. Therefore, somehow this has to be changed. And when I look at the radius is always changes, and is nothing except that vertical line which it touches x-axis and the function from the top. This is called direct distance away from the x, and that direct distance is called a y. Therefore, your radius is y. R squared become y squared. Therefore, that's become from 0 to 1 pi. Your r is y squared dx, but still they are not same fabric. But I know my y is square root of x, you square it and you get dx, and you can evaluate that one because that's become pi, and the integral of x become x squared over 2 from 0 to 1, and the volume was pi over 2 unit cube. Then we moved on to calculus 3, and we did double integrals. We said if you do have a region, and your region is containing y equal to x squared and y equal to square root of x, they said this is your region, and the region make it, you can divide it either your x, these are all delta x, and all of them are the same, and basically this is called 0, 1, b minus a over n. You divide it to so many rectangles, then that one could be divided by 10, 20, 30, 40, 50. Then you go ahead and divided the region into a horizontal one, and you pick up one of these rectangle, but in here the delta x is fixed for all of them, but my y is changes because my y goes up and down. Therefore, in here my x was fixed, my y, the lower function bottom was x squared, the top function was the square root of x, and the area of one of them is either dy dx, because here I have to write it as an differential, and if it's outside the integral, you write it as a delta y delta x. Or I can write it as a dx dy. Which one do be right? Remember, the permutation is 2 factorial, and you can write it 2 different ways. In here, you have to look at your how did you split your region if you made your x fixed or your y fixed? If your y was fixed, this become a dy, and you make my y fixed. But your x varies. And since your x varies, you have to say right minus a left. And your right is y equal to x squared. Right and left, you have to solve for x in terms of y. And that becomes a square root of y. Therefore, that left, that right is a square root of y. And the left is y equal to a square root of x. When you solve for x, that becomes y squared. And say these are exactly the same, but in this one you have to do with respect to y because the y was changing and the outside was dx. Therefore, you're going to have the same answers right here. No problem at all. But somebody said, you talked about volume over here, but these are area. If you take the area of a region and multiply by the height, which is your z has to be function of x and y. Therefore, if I put x squared, y squared for my z, and if I put dy dx in here, from x squared to a square root of x and 0 to 1, that gives you the volume. Means, if this point right here, I'm assuming if it's 1/2 and 1/2, at that point the height is going to be 1/4 times 1/2 and it's 1/8. Therefore, the height is always varies and determined to those order pair. Therefore, that's the volume. Then somebody said, but what happens if this is not a volume and that represents the density? Then you cannot call it a volume. That's another application, which we call that one the mass. Okay, then somebody else said, if you have a region and if you divided the region to infinitely many rectangles, these are all parallel to the x and these are parallel to the y, and I'm going to pick a region and I'm just going to make it up, and my region is going to be right here, and that's my region. But this is the base area. If I moved every one of these corners, you will end up with a prism. And it is possible the height of each of these prisms, I should have talked about inside the region. The height of each of these prisms, which there are many of them, are going to be different. Why they are different? Because they have different ordered pair. Therefore, all of the height is defined by that. And I just made this one up. And somebody said, how do you find the volume of that one? You can use double integrals. And you only consider the region and put your z as a height here, and have either dy dx or dx dy. But if I'm going to assume this is a parabola, and that parabola is going to become y equal to x squared plus 6x, therefore, when y is 0, let me put a negative right here. When y is 0, your x's go from 0 to 3. Therefore, I make my x fixed and go 0 to 3. But my y varies. All these y are varies. I can write my y from 0 to x squared minus 6x. But sometime they said, please, instead of a double integral, write a triple integral and say right here, I know this one is the change in x. I know this one is the change in y. And I know all the prism gonna have a different height. And let's call this one the change in z. And the volume of a prism is dz, dy, dx. And they said, why did you write dz, dy, dx? First of all, there are 3 variables. You can write it 6 different ways. But it is your option what to pick for your region. The region is given to you. And if the region is this, you have to determine, are you going to make your x fixed or your y fixed? If it's a function of x, x fixed is a lot easier. If it's a function of y, y being fixed is a lot easier. Therefore, I'm going to make my x fixed and go 0 to 3. But my y is go from the bottom to the top, which is x squared, bottom is 0, and x squared minus 6x. But what is your z? If I'm talking about the first octant, they have to let you know, your z here is 0, and the top z is right here, because I told you this is your z. Therefore, you go from 0 to x squared y plus 5x plus 3. And that will give you the volume, and it's going to give you the same answer as that one, because when you the same answer as that one, because when you integrate z 1 dz, it becomes z, and it becomes from 0 to that one, and this is exactly what you have right here, and this is dy dx. Okay, then somebody said, why do I have to study triple integrals? I know how to find the volume in a double integrals. Then I'm going to mention, as long as the coefficient is 1, is the volume. If the coefficient is 2, you can pull it out. You double the volume. But please remember, one of the applications said mass is rho times the volume, and sometimes you have a 3D graph, and that 3-dimension solid is not, the density is not uniform across. The density at this point, this point, this point, this point, this point, this point, every point the density are different. It depends at what location you are in. Therefore, your density really depends on the order triple x, y, z. And let me call this one x squared plus y, z. And I said, that's my density. And I said, what is the mass? It's rho times density. Then that density has to come over here. And this is no longer called a volume. That's called a mass. Therefore, you have no choice to study the triple integrals. Because in the future, if you want to find the mass of a 3D or a solid, you have to do it through a triple integral. How does triple integral works? Number one has to be fixed. It doesn't matter if it's x or y or z. You have to determine your region. A region is your base area, and this is between x and y. See which one is x, which one is y, and see which one is easier to fix. Therefore, if it's a function of x, I recommend you to make your x fixed, because when x is 0, y is 0, x is between 0 and 3. Then your y cannot vary, because if this is equation of a parabola, my y is going to be changed for every one of these points. Therefore, since the y changes, you have to say your y go from 0 to x squared minus 6x. Remember, this one doesn't match my graph, but that's what I meant. Then, x have to be fixed between a and a b, and b must be greater than a. Your y must be bounded between two functions, h2 of x and h1 of x. Therefore, h2 of x must be greater than h1. Therefore, 1 can be fixed, but y has to be a function of the outside. And z does have two options. Can be function of x and y both, can be only function of x, or can be only option of y. The maximum can be function of x and y. Therefore, I call this one f2 of x and y. And here is f1 x and y, with the guarantee that that's become your z. Therefore, here, if I have z equal to, I'm going to make some other number up, the square root of x squared plus y squared, and say this one, my z is equal to 16 minus x squared minus y squared, and that become a dz, because this is a function of x, I bet you the first one is a dz. The second one is a function of y, I bet you is a y. The last one is a constant, I bet you is a dx. Therefore, you know you have to study your triple integral. That's very important. Let's do some examples. And the examples I'm going to pick is not an easy one, but I'm going to make something up. 9 minus x squared. Well, somebody said, what is the graph of these? Because it has two variables, in 2 dimensions, the graph is going to become a parabola faces down. But somebody said, what is it in 3D? In 3D, there is no z value. Means z can take 0, z can take 1, z can be 2. Therefore, if I write here, as we mentioned in the class many times, x squared y squared equal to 4, in R2, this is a circle. With R3, you can graph this one as z equal to 0, z equal to 1, z equal to 2, z equal to 3, z equal to 4, and you get a cylinder. Therefore, that is a cylinder in R3, but in R2 is a circle. In here, it is a parabola in R2, but in R3 is a cylinder. Because your y is 9 when x is 0, and when y is 0 is x plus minus 3. Therefore, you know this is going to be a parabola. But somebody say, what happens if I go to z equal to 1 and I graph it? Still you have a 9, and then you have a 3 and a 3, you have another parabola. Therefore, you know the tail end is going to be pretty much like a straight line, and then you have parabolas just sitting on this one, just like this. Okay. Then I'm going to give you another equation, and I'm going to say this one is y equal to 2x squared plus 3z squared. In here, I'm going to say if the z become a constant, like 1 or 0, if the z becomes 0, on the x and a y, that's going to be a parabola. And what is the parabola? When x is 0, y is 0. When x is 1, y is 2. 1 is 2, and when it's negative 1 is 2. When x is 3, that become 18, and negative, this become a negative 18. But somebody said, what happened if the z become 1? Therefore, that would become a parabola that shifted up 3 units. Everything else is the same. Therefore, when you go up 3, you still have the same parabola as this one, and at the z equal to 3. Okay, then this is nothing except a parabola on the y-x, a parabola on the yz. Let me do it. YZ is a parabola, YX is a parabola, and this is called paraboloid. Therefore, I know this is my right function and this is my left function. Therefore, I know my y value. The right function is 9 minus x squared, and the bottom function is 2x squared plus 3z squared. And I know I have a dy right here because my hardest part was your y value, and my y changes, but I have to know which one is the left, which one is the right, which one is the left. Next, I'm gonna go eliminate the y because I have already used the y. These two equations are equal to each other. Therefore, I'm gonna have 9 minus x squared equal to 2x squared plus 3z squared. If I took the x squared to other side, that becomes 3x squared plus 3z squared. And if I divided it by 3, you have 3 equal to x squared plus z squared. That is the equation of a circle with the radius of a square root of 3. Right now you have an option. Do you want to make your x fixed, or do you want to make your z fixed? I take my z fixed, and I said my z is from radical 3, because my r is the square root of 3. Okay. But when I look at this one right here, let me see here if my z, that's good. Therefore, my z is going to go from negative radical 3 to a square root of 3. But I need my x. My x is plus minus square root of 3 minus z squared. Therefore, the last one was a z, and middle of it I'm going to put x. And the bottom one is negative square root of 3 minus z squared, and the top is plus the square root of 3 minus z squared. That's become the volume bounded between these cylinder and this paraboloid. And somebody said, goodness, would you solve it? Yep, the problem is not hard. First, you have to do the inside integral, and the lower limit and upper limit must be function of x and a z. It does look good. This one has both of them, this one has one of them. Therefore, when I integral 1 is y, and it has 9 minus x squared, 2x squared plus 3z squared, and that becomes 9 minus x squared minus 2x squared minus 3z squared, and that becomes 9 minus 3x squared minus 3z squared, and is 9 minus 3 x squared plus z squared. Okay, I got it. That's pretty good. Let's do the outside too. I have 9 minus 3 x squared plus z squared, but I do have here a dx, here is a dz. My dz was from negative radical 3 to a square root of 3. My x was from negative square root of 3 minus z squared and plus square root of 3 minus z squared. How did I get these two? I got these two from the circle. And these four limits provide you with a region, and that's my region. Would you tell me what is my region looks like? My region, it looks like a circle with a radius of a square root of 3. When you have a circular region, it's a lot easier to cut it in a sector than a rectangle. Therefore, your R changes, therefore you want to find the volume of area of one of these and take care of it. And how this go to become to a sector? dx dz become r dr d theta. Region is complete revolution. You need from 0 to 2 pi. In every one of these rays have same length. Only the r of a circle with the center at 0 are the same. Sometimes when you have a pole, you have some kind of a graph like cardioid. Those are not the same. Therefore, the r varies. Therefore, this is the bottom one and that's the top one. But in here, I need my r. And my r is fixed from 0 to a square root of 3. I took care of these. But what I got to do with that one? This is 9 minus 3, but x squared plus z squared is r squared. Somebody said, no, that's not a y squared. Yes, sir. This is your x-axis, and this is your z-axis, and that is x squared plus z squared equal to r squared. Okay, then pretty much I'm done. In here, I'm going to multiply 9r minus 3r cubed dr d theta. I don't think I need to continue this problem because anybody can do it. That's 9 r squared over a 2 minus 3r to the power of 4 over a 4, 0 to a square root of 3. And when I square the radical 3 become 3. 9 times 3 is 27. To the power of 4 become 9. 9 times 3 is 27 over 4. I multiply by 2. That's 54 minus 27 is 27/4. I may have made a mistake on the calculation, but I'm sure you're going to check it. Next, you have to do the outside. And you have to go in here from 0 to 2 pi d theta, and that becomes 27/4 of a theta from 0 to 2 pi. And the volume is 27/4 of 2 theta, which is really 27 pi over a 4 unit cube, because I find the volume. Bounded by these two, a cylinder and a paraboloid. Let's do another example and let's finish this video. I'm gonna have a solid of these, x squared plus y squared. You know, if the z becomes 0, you have a point. If the z becomes 1, you have a unit circle with a radius of 1. If the z becomes 2, is the radius of 2. z3 is a radius of 3. Therefore, you know the graph of that one is a cone. I'm going to give you something else, and I'm going to say x squared plus y squared plus z squared. Let me think what am I going to put for my r. And let me put 8. Therefore, your r squared, here I really shouldn't call it r because r is for the circle. I'm going to call it rho. Rho squared is 8, and your rho is 2 square root of 2. Then 2 square root of 2 is 2 times 1.4 is almost 3. I go 3 here, and 3 here, and 3 here, and 3 here, and you're gonna have a circle. Man, it's so ugly. Circle here. But this is a sphere. Therefore, how I am going to, and then you have to go back and say, okay, your z was 0, then make your y 0, you have another circle in the x and y direction, and then x and a z direction, and the y and a z direction. You have 3 cross sections, 3 circles. Then I'm going to say, oh, that's my top function, and I want to know where do they intersect. Therefore, all I need is a top, which is x squared plus y squared. This is the sphere, plus z squared equal to 8. But that sphere touches the cone, and at that point they have same height. Therefore, the z value is the same. And what is the z for the cone? Square root of x squared plus y. And when you square it, it becomes x squared plus y squared. Therefore, you have 2x squared plus 2y squared equal to 8. And x squared plus y squared is 4. Therefore, I know the top region is going to become that circle. Okay, we got it. We're going to say, first, I'm going to put a dz here. Okay, what is my z here? My z in the bottom is the square root of x squared plus y squared. What is my z here? You got to solve for a z and take the positive. Is 8 minus x squared minus y squared. I got it from that one. Okay. That was your dz. Right now, I have to look at the projection of that region onto my xy plane. The projection is right here. That's your region. That's your region without a what? That's your region without the sphere. Because you're talking about the region right now. And you know my y value, I'm going to make my x fixed. My x is from -2 to 2. I don't know, we always get the x fixed, but I think we like it. And my y is going to become square root of 4 minus x squared minus, and this is 4 minus x squared plus. And this become a dy, and that become a dx. Well, pretty much got it. If they ask you that the density of that surface, which is a cross section of these two surfaces, is this, then you can put your density here and find the mass. But right now they said the volume, the integrand is 1. Well, you know what though? That's your z. What is your z? 1 dz when you integrate it is z, and it's from x squared plus y squared over 8 minus x squared minus y squared. Therefore, your z is 8 minus x squared minus y squared minus x squared plus y squared. Now, I'm going to do my region. And this is my dy, this is dx. You know what? There is no way in the world I can integrate that. Because your inside function is x squared minus y squared, negative x squared, and I need an x outside, or I need at least a y outside. I cannot do it. That's going to be very tough. But what was my region? My region was x squared plus y squared equal to 4. That's round. Your r is always 2, and your theta is from 0 to 2 pi. Therefore, I'm going to change this one to a polar form and set 0 from 2 pi. My r is from 0 to 2. And in this problem, instead of that one, I put 8 minus, I factor it. 8 minus x squared plus y squared. And x squared plus y squared is r squared. Minus that one, x squared plus y squared is r squared. And all of them is r dr d theta for the place of dy dx. This one is 2 integrand, and I'm going to write as 2 integral. That's the difference of integrand. I write as a 2. I put 0 to 2 pi, 0 to 2, 8 minus, let me see if that 8 minus r was on the radical. That 8 minus r squared was on the radical, and I forgot. 8 minus r squared on the radical, and I have r, the r d theta. Right now, do you see? That's your u, and that's your du. Minus double integral 0 to 2 pi, 0 to 2. But what is the square root of r squared? Is r times r is r squared. This is not hard to do, and in here you can do it by your substitution, and you can find the answers. Do you see triple integrals? Eventually, you have to learn it, and would be very helpful if you can change the last two to the r d theta, but I left the z as it was. Therefore, this is contained of r, theta, and a z. That's the different from x, y, z. This is when the base is round and the height is straight. This is called cylinder. And in a very, maybe next 2 video, we're gonna talk about cylindrical coordinate. Cylindrical coordinate is nothing except r, theta, and a z, which you really do not change the z. You keep the z as it is, but you can move the outside to r d theta. And that's exactly what we did in here. Thank you. Have a great day.